Hi students, I hope you have watched my previous two lecture video which was basicity and nucleophilicity and living group. If you have watched, if you have seen, then it will be very easy for you to understand the Sn2 reactions. I use some chemical kinetics terms here to better understand the Sn2 reactions. So let's start the Sn2 reactions now. See students, I have used here, there is a biomolecular nucleophilic substitution reactions here. So second terms is what? Second terms is that biomolecular, and obviously substitutions, nucleophilic substitution reactions. So I have written the two reaction. One is simple reaction CH3X plus OH negative. OH is a nucleophiles, and that is replaced in the form CH3OH plus X minus. So I taught you in the previous video what X minus is the X is the better living group, so OH minus can easily replace to X negative, so that the reaction will form like that. So if we write in the wedge and dash form in the 3D structure like that, we can write like that, right? So one is H, 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 and there is a X. Okay, so nucleophile attack from the back side, and what the important things is here is to the transition state will be a pentavalent. When you read the NCERT, there is also line is given, the pentavalent structure will form. So this is the pentavalent structure. It means what? One nucleophile will slowly or simultaneously attached to the carbon. At the same time, the living group will leave the positions. So this is the pentavalent. It means this nucleophile and the living group will be half up. Neither nucleophile will completely attach nor living group will completely leave the positions. But you can see the pentavalent. Due to pentavalent, it forms the triangular bipyramidals. Correct? But see the hybridization sp2. Why their hybridization is sp2 in the transition state? Because neither this bond is permanent, neither nucleophile is. Means now the nucleophile and living groups attached. Slowly nucleophile will come, slowly living group will leave the positions. So in any reactions, the two processes simultaneously happen. In any reactions, when the two processes simultaneously happen, that is called concerted reactions. Clear? So why it is called concerted reactions? Because especially in the transition state is called concerted state. Why it is called concerted reactions? Because in the Sn2 reactions, we have seen in the transition state, where is the nucleophile and living group simultaneously takes places at the same time. Clear? So what we can say, concerted reactions, bond breaking and bond formation takes places simultaneously. Clear? Now here is, so what happened? Students, see that this bond is like that. So when nucleophile will attach, there will be the inside out umbrella. You have seen usually in the rainy seasons or wind times, when you are moving with the umbrella and you are going against the winds, and suppose you nucleophile attach from this side. When you attach a nucleophile from this side, what will happen? And your rest of the substances, rest of the atom will like that, means inside out. For example, what I am talking about, when you are going somewhere with the umbrella and winds is opposite with you, then what happen? Umbrellas completely will be inside out. Am I right or not? So when all the atoms, hydrogens and hydrogen like that, when nucleophile attach, what happen? The rest of the atom will completely inside out. This is called umbrella effect. Understood? Why it is called umbrella effect? Because the similar behavior of umbrella, the winds is against the winds, you are going with the umbrella, so taking the umbrella, and what happen? The umbrella is inside out. Okay. So now therefore I have written that this is also called inversion or configuration or Walden inversion, right? Or umbrella effect. Now especially for the engineering students I am talking about, the graph is not too much important for NEET students, but if you understand, that's very nice. You can solve easily objective questions. See here, students, the Sn2 reaction is exothermic process. Clear? So exothermic because one bond is formed. So exothermic process, and earlier I said I will use the chemical kinetics terms student C. In any exothermic reactions, when we go with the progress of the reactions, what happen? So suppose this is the amount of the reactant energy, and exothermic reaction means what? Graph will come here. Done. So here is CH3 Cl plus OH negative, and here is what will happen? CH3 OH will form. Means here product is going to be formed. See, here the product will form. So this is the amount of energy of product energy. This is the energy of reactant energy, and here is the activation energy. Already we have done in the chemical kinetics. So what I would like to tell you, if I want to calculate the energy of the reactant, difference of energy of reactant and product, so this delta G star is the what? Energy difference of the reactant and the product. Am I right or not? Delta G is the energy difference between reactant, this is reactant, and here is the product. Okay, and this amount of energy is the difference of, see, here is the transition state. This is the transition state energy, and here is the reactant energy. Means what I am talking about, when the reactant, before the reaction starts, reactant definitely contains some amount of energy. So we assume that the reactant have energy, and when the transition state is formed, what the amount of energy difference between reactant energy and transition energy. Clear? So here we can say that delta G star star. So delta G star what defines? Delta G star defines the energy between transition state and the reactant energy. Clear? Delta G plus what defines? Delta G defines the energy difference between the reactant and the product. Clear? Delta G plus what define? Delta G plus define between the transition state energy and the reactant energy. Clear? And the delta G plus what define? The reactant energy minus product energy. Clear? This graph is not neat student can ignore, but if you understand, that's very nice. Okay, now I'm talking about student C. We have seen in the chemical kinetics, we have a study in the chemical kinetics, if any reactions is elementary reactions, order and molecularity both are same. Since Sn2 is elementary reaction, hence their order and molecularity both are same. So how you can predict the molecularity of elementary reactions? Elementary reaction means what? The reaction which completed in the single step. Clear? So you can see here is a 1 mole of CH3X and 1 mole of OH negative. Clear? That means their stoichiometry is 1 and 1. So we can say that there is a molecularity is 2, right students? And since it is a elementary reaction, so we can assume that their order is also 2. Or we define the order by rate law expression, right? So their rate is alkyl halides and nucleophile, means Sn2 depends on both the alkyl halide and nucleophile. And here is a 1 and here is 1, 1 plus 1, 2. So either you can say that here is order is what? Sum of the rate law expression is called order. So 1 plus 1 is 2 order, and here is the 1 and 1 is the 2 molecularity. But simply you can understand elementary reaction order and molecularity both are same. Therefore, molecularity and order both are same. Since there is no carbocation is formed, so in the Sn2 there is no carbocation is formed, students. Since no carbocation is formed, hence no intermediate will form. No intermediate will form, no carbocation is formed, there is a probability of rearrangement is 0, because rearrangements where happen, whereas the carbocation is formed. Clear? There is no carbocation means rearrangement is 0. Okay, I earlier said it is exothermic reactions. Okay, now the most important logic here, students, most students confused about, sir, why we take the less hindered substrate, because alkyl halide and a nucleophile. So why we take the less hindered alkyl halide. And second, why we take the polar aprotic solvent and what the effect of polar aprotic solvents, because student usually reaction will be given and the amount solvent is given, and then you have to predict the reaction will move into Sn2 or Sn1, correct? So the solvent is very very crucial, students. So why polar aprotic solvent will take? Okay, now I am going to, I have already I discussed with you the in the next page. Second is the electron withdrawing group increases Sn2 reactions. Why it happened? Why electron withdrawing group increases Sn2 reactions? All the three things we are going to understand here. See, students, see here, larger and bulky group hindered the formation of transition state, and the crowding increases, therefore energy of activations increases and reaction will be slowed down. I am telling you one thing. Student, suppose the road is narrow here and from one side a truck is coming and the other side you are going by a scooty or by bike. Road is very narrow. What happened? Both, neither truck will pass on, neither you can go. So here what happened? Jam will be happen. As a result, the backside, so many vehicle of truck and the backside from you all will be stuck here. There will be a jam, so that the rest of the vehicle will come slow. Am I right or not? It's happened in the when you go to the metropolitan city. So in that process, similarly, student, when you take the bulky group and your nucleophile is there, when the bulky group and nucleophile both will come, right? So that the around the bulky group, the crowding will be happen. As a result, the crowding always hindered the formation of transition state. And the more crowding means reaction will go slow. Why? Because energy of activation will be high. And we have done in the chemical kinetics, when the energy of activation is going to be high, reaction is going to be slow. So if any reaction activation energy is high, reaction will be slow. So why here activation energy is high? Because one side nucleophile is coming, second bulky group is coming. So when both will meet to each other, so near the bulky group, the crowding will happen. The crowding means what? Here is the methyl, here is the methyl, here is the methyl. So nucleophile have no too much space to attack on the center. As a result, the transition, it will be very difficult to form the transition state. And since the transition state will not form, it means why transition state will not form? Because the crowding area is there. As a result, energy of activation means you have to require, or reactant and nucleophile will require more energy to form the transitions. Am I right or not? When the jam will happen, you want to cross the jam, what will happen? Either you or opposite persons will require the more amount of energy, or somewhere you will try to find the roads, different roads. So it means what? You have to require more energy. When you use the more energy, obviously everything will be slow. So when the nucleophile and the substrate will cross to each other, so in that case they try to find the transition state, and that is the regions their activation energy is going to be high because the crowding is here. And the one more example I have given you here, the beta carbon. See here, halogens attached with the carbon is the simple alkyl halide, but beta carbon is attached with the two carbons. Despite being it is the 1 degree halides, but it will not move into the Sn2 reaction smoothly, because when students feel that okay, this is the Sn simply methyl halide, so it would be the it will move into the Sn2 reaction easily. Students, that's wrong. When the beta carbon, this is a simple rule, when the beta carbon has too much hindrance bulky group, there will be very very difficult to move into the Sn2. Keep in mind. So here is it will be very difficult to attach the nucleophile at the first carbon. So obviously it will be faster than here is a 3 degree alkyl halide, but still it is a very slow reactions, because beta branch is very slow substitution reactions. Keep in mind. So I have written here the order: methyl, primary, secondary, and neopentyl or tertiary. So I hope you understood why we cannot take the bulky substrate because energy of activation will be high and reaction, so it will be very difficult to form the transitions. Now the next question is coming, sir, why we take the polar aprotic solvent? Why we not take polar protic solvents? What is the reason? See here. Student, I have given the two example. What will happen when we take the polar protic solvent? See here. Every nucleophile contains cations and ions. Correct? Suppose you are taking that KOH. KOH also contains K plus OH negative. So every nucleophile contains cations and ions. When this nucleophile is going to dissolve into the polar protic solvent like ROH, see what will happen. See students, Na plus will form the bond with the ROH, means oxygen have lone pair, so that can donate the pair of electron to sodium and it form the coordinate bond. Clear? Okay, now it's time for nucleophile. Br minus also attach with the hydrogen atom of the alcohol. Are you understanding what I'm telling you? Every nucleophile contains negative and positive. When you take the polar protic solvent, so metals attach with the more electronegative atoms of the polar protic and form the coordinate bond. Nucleophile, which is the Br negative, will attach with the hydrogens, although it is not a strong hydrogen bond, but it will form the bond. So nucleophile will engage here. It means no free nucleophile is there. Correct? And why the free nucleophile is required? We understand in the polar aprotic solvent. Student, polar aprotic, I have taken that polar aprotic solvent like DMF, DMSO or acetone. See what happen. Na plus here will form the bond with the oxygens. Clear? Okay. But in this time, Br negative is not able to form this compound because here is already bulky group attached there. Clear? Now the question is, sir, why Br negative will not attach with the hydrogen? Students, yes, it's possible, but here is the what? Carbon already combined with the oxygens. There is here is the use the bulky group there and CH3 group there. So it means and the bromine is already bigger size, as you know. So it is very, very difficult to attach these positions that bromine. Suppose the carbon is single bond, then it would be possible. But here is the already it is a very, very bulky group already attached with the bond. So Br negative is not able to form the bond here. So Br negative means free nucleophile. Free nucleophile is called aggressive nucleophile. Done. So aggressive nucleophile, why it is called aggressive nucleophile? Because initially nucleophile was cations and anions. Now cations involve the bond formation. Anion is alone. That anion is called aggressive nucleophile. Now aggressive nucleophile react with the substrate and easily form the product. So keep in mind, in the polar protic solvent, no nucleophile is free. Means no nucleophile is aggressive nucleophile. Clear? So student, what happen? Sometimes suppose someone saying that you can't do anything in your life and your ego is hurt, and you take the challenge and you accept the challenge and do something. It means someone's hurt your ego means what? You know you are become so much aggressive to do anything. Exactly, any nucleophile is aggressive means more aggressive nucleophile means more easily substrate can form the product, reactant can form the product. So in the polar protic solvent, no nucleophile is free, hence no reactant will easily convert into the product. But in the polar aprotic solvent, there is a free nucleophile, means aggressive nucleophile will form. As a result, that will involve in the Sn2 reactions. Clear? So I hope you understood that why substrate we cannot take the complex. Second, why we can take the polar aprotic, not a polar protic. Clear? Now one more additional take the knowledge. Chrome ether also form Sn2 reaction. Student, chrome ether is what? See, chrome ether is like that. Here is the chrome ether. There is the chrome ether. Okay, here is that like that chrome ether. This is the chrome ether, students. So in the chrome ether, here is the chrome ether like that. So here is what cations will come. So cations will come means anions will be free. Since anion will be free, hence reaction will involve in the Sn2 reactions. Okay, next is that what will happen when electron withdrawing group will takes place. So why Sn2 reaction will be faster in the electron withdrawing group? Okay, understand here. Student, I have taken that here is the carbonyl compounds along with the halogens. Okay, so what will happen, students? When you take the carbonyl compound electron withdrawing group, I have taken here, understand, nucleophile here, nucleophile is electron rich. So nucleophile attack where the electron is deficient. Okay, halogen is a better leaving group. So when halogen will move, cations will come here. Now come carbon and oxygen also there. So when the oxygens will move, electron will be taken by the oxygens. Here cation charge will come. It means the charge of nucleophile will polarize on the two positions. Clear? Suppose you have a 3 electron withdrawing group, then the charge, nucleophile charge will polarize on the 3 groups. Clear? So what happened, and you know already the more charge separation, more charge polarization means stability will come. So what happened, I have written the transition state also here. So as a result, but ultimately what happened, nucleophile attach on the halogens, but initially nucleophile has 2 options to attack there. Clear? So ultimately why nucleophile attach here, not the carbon oxygens? Because as you know the halogen is better leaving group. So nucleophile believe that when the halogen will move, this position will be available for attack on the nucleophile, attack on this position, because that contains the carbocations, because X is a leaving group. But as compared to oxygens is not a better leaving group as compared to halogens, right? So ultimately the nucleophile will attach on this group, not a carbon. But initially what you can see here, both the polarizations, both the center was available for attack on the nucleophile. Okay, so now I have written the order here. The excellent Sn2 reaction will involve in the alpha beta carbonyl compound. Excellent, because there is electron withdrawing group is there, and then methyl halides students. Now lot of students confuse that benzyl halides or allyl halide will involve in the Sn2 or Sn1. Students, keep in mind one thing, when you have taken the very good nucleophile, both will involve in the Sn2. When you take weak nucleophile, both will involve in the Sn1. Clear? What I am saying, when you take the very good nucleophile, that will involve in the Sn2, otherwise will involve in the Sn1. But both involve in the Sn2 and Sn1 both. And student, one more thing, aryl halides and vinyl halides not involve in the Sn2 reactions. Okay, so now I have given on the basis of this, there is one example. Suppose potassium iodide react with the acetone. So I have taken the potassium iodide and the acetone. Acetone is the polar aprotic solvent and potassium iodide is a nucleophile. Now my question is, what will be the rate of the reaction of Sn2? Just you pause the video and think about it. Acetone, I have taken the potassium iodide. Students, see, here is the S carbonyl group, more electron withdrawing group. Obviously S will involve faster. Clear? And after beta carbonyl group, which will involve methyl halides. So after S, what will happen? P. After P, then R, because allyl halides, and then the 2 degree. Clear? One more thing is that, suppose I ask you the questions here. You have a pen. Okay, chloro. Here is pentane and cyclopentane chlorides, and here is the cyclohexane chloride I have written here. Okay, so now my question is, where the Sn2 will involve faster, cyclopentane halides or cyclohexane halides? Where will involve faster? See students, actually you have done that when we go to the that group like that. Here is the butane, here is the propane, here is the propane. Okay, and here is the pentane. What happened? The more crowding here, because of angle strain, more crowding than this here, then cyclopentane, minimum crowding in the cyclohexane. Clear? I'm not going to involve in the why crowding happened because it is an isomerism topic. So, but you keep in mind that the when you go chain increases, crowding decreases, right? So in that case, on the basis of crowding, the Sn2 should be faster in the cyclohexyl halides than the cyclopentyl on the basis of strain I'm talking about, hindrance I'm talking about. But there is also one exceptional cases here between cyclohexane halides and cyclopentyl halides. See here. Students, I have written that the order here, cyclopentyl halide, cyclohexyl halide and cyclobutyl halides. Why it's happened? Why cyclohexyl halides is lower than the cyclopentyl halides? There is a one exceptional reason. Because when you draw the structure of cyclohexyl structure, so what happened? The chair and boat conformation you have done in the isomerism. So cyclohexane will involve in the chair and boat configuration, as you know. So when you write their axial position strains, so when the cyclohexane is moved into the axial position, you can see here the two hydrogen is very close there, right? So this two hydrogen is very close means too much crowding area. Clear? So therefore nucleophile attack on the other axial positions. Am I right? So as a result, the leaving group will move from the equatorial positions. So simply you can understand a cyclohexyl halides will reaction slower than the cyclopentyl halides. Rest order is okay because of steric hindrance at the axial positions. Clear? So I hope you understood that where the Sn2, why the polar aprotic solvent is required, and second, why crowding is not necessary. Crowding is absolutely, if you take the crowding means reaction will negligible will involve. I taught you both the things. In the next video lecture, I will bring the 10 important questions of Sn2 that will clear the absolutely concept. And next to next video will be the Sn2 reaction of NCRT method of preparations on the basis of Sn2 reactions. You must watch all the video lecture so that you can understand perfectly that because my aim is to crystal clear your concept should be crystal clear of all the every topic, so you don't miss every topic. You watch the video lecture, and if you feel that you understood, subscribe, share. Why share? Because your friends would understand that better way, right? And subscribe because next lot of video, important video and lot of explained video will reach at you. Okay, thank you.